Welcome back to the Screensavers. We're on the verge of a huge anniversary in the world of theoretical physics. And our favorite theoretical physicist, Dr. Michio Kaku, has just written a new book about Einstein. He joins us now via satellite from New York. Welcome back to the show, Dr. Kaku.
Glad to be on.
So I got a first question for you is, why a new book about Einstein now?
Well, you know, next year is the 100th anniversary of the founding of relativity, and the United Nations calls it the Year of Physics. There are a number of science documentaries about Einstein coming out next year, a number of international conferences, so it's going to be an Einstein renaissance.
So tell me, for people that aren't familiar with all of Einstein's discoveries and theories, what wouldn't be possible in today's tech world without Einstein's theories holding true?
Well, the simplest example would be the GPS system. In fact, the GPS satellites would be off unless you put relativistic corrections. Not to mention all of electronics. Television, electronics, your PC would simply not function without relativity. Not to mention the sun itself. The sun itself would cease to shine if it wasn't for E equals mc squared. So when people say, what has relativity done for me lately, just realize that all life on Earth depends upon Einstein's theory of relativity.
So what more recent Nobel Prizes are we seeing as a direct result of Einstein's work?
Well, you know, some earlier biographies said that Einstein's theory was finished, it's old-fashioned. We have to realize that Nobel Prizes today are being given for crumbs that are falling off Einstein's table. That's because we have a whole new generation of space satellites, lasers, gravity wave detectors, and they're winning Nobel Prizes for the current generation of physicists. For example, in outer space, we have two dead neutron stars chasing each other, releasing gravity waves. And because of that, the Nobel Prize was awarded to two physicists for calculating the rate at which two neutron stars go into a death spiral because of Einstein's theory.
Yeah, I was going to say, we do have lasers and we have technology, the internet, and all these things. Now, Einstein didn't have, how did he have such incredible foresight without having near the technology that we have today?
Yeah, you know, when he made his theories, he said to himself that maybe some of his ideas would take 100 years to test. And sure enough, 100 years later, we do have the space satellites and we do have the laser beams that can test some of Einstein's theory. But I think the secret of Einstein's success, the reason why he was 100 years ahead of us, was because he had a childlike quality. He asked questions like, what is light? What would it be like to race a light beam? What is space? What is time? When we grow up, we learn not to ask those questions anymore.
Right.
But Einstein had that childlike quality. He never let go until he finally understood the secret of light, the secret of space and time.
So what's the next big breakthrough, given that there is like a theory of everything?
Well, that's what we're chasing after right now. We're looking for places where Einstein's theory begins to fail. Now, at the present time, we have seen no deviations in our experiment from Einstein's theory. However, now that we have black holes that we can see with the Hubble Space Telescope, we want to push the limits to see whether relativity breaks down at the center of a black hole, or maybe the instant of creation itself. We can detect radiation for the Big Bang now. We have baby pictures of the Big Bang, and we want to see whether or not Einstein's theory breaks down there. And ultimately, as you pointed out, we need a theory of everything. And that's what Einstein was chasing after for the last 30 years of his life.
So tell me about the theory of everything. What is, for someone that doesn't know, explain that a little bit.
Well, we have four fundamental forces that rule the universe. We have gravity, which is worked out by Einstein's theory. And then we have the quantum forces, the forces of the atom, the two nuclear forces, and also the electromagnetic force. And a theory of everything would be a theory which combines Einstein's theory of gravity with the quantum theory of the atom. And if you could combine these two theories, you would have the sum total of all physical knowledge, perhaps in an equation 1 inch long. Now think about that. E equals mc squared unleashed the power of the sun. That's the secret of the stars. E equals mc squared. We want to find an equation just like that, which will be the secret of the universe itself.
If you were able to find, let's discover the theory of everything, you found the equation, what would that mean to mankind?
Well, in the short term, nothing. We're not going to get better color television. We're not going to get better toasted bread because we found the unified field theory. However, the unified field theory will ultimately answer some of the deepest questions about space and time. For example, what lies on the other side of a black hole? Can time travel take place by going through a wormhole? What happened before the Big Bang? How will the universe eventually die, and can we escape the death of the universe itself? These are cosmic questions which can only be answered by going beyond Einstein to a theory of everything.
Wow. So Time magazine named Einstein the person of the 20th century. What do you think it would take for a physicist to be the person of the 21st century?
Well, I think a lot of us physicists are asking that question. I'd say that Einstein ranks way up there with Isaac Newton in terms of his contributions to science and humanity. And a lot of us are trying to see whether we can then extend the work of Newton and Einstein to a theory of everything. We want to complete that dream of a grand synthesis that would allow us to, quote, read the mind of God, unquote, to read his thoughts. That's what Einstein wrote in his diaries and memoirs. He had hoped to tap into God's thoughts. And that's what we physicists are trying to aspire to at the present time.
That would be amazing. Thanks so much, Dr. Kaku, for your time.
My pleasure.
That was theoretical physicist Dr. Michio Kaku. Find out more about his book, Einstein's Cosmos, at thescreensavers.com. Now, don't go anywhere. We have a lot more screensavers coming right up after this quick break.